Friends, my name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences, grades 9 to 12. Today, I am delighted to take you through our paper which we did in Term 3, Informal Test. I believe as we revise this paper, we're going to understand, because it contains most of the questions which other teachers said for you guys. And now those learners from our tuition center at Rostec College, that is Math, please enjoy the paper and feel free to ask. Then those learners at our school, Northern, please get the question paper, and as you watch this video, please do the corrections again so that you can prepare for your test, which is coming on the 28th of September 2021. That is next week, Tuesday. Okay, now my name is Patrick Kamala. Again, I am a tutor and educator for mathematics and physical sciences. Let us start. So as we do this, please understand. Don't cram, understand. Okay, let us proceed. Now, question 1 is saying that an object moving at a speed v has a kinetic energy E. The kinetic energy now changes to a quarter E. The speed of the object is now, so note something, they're saying that the object has got kinetic energy E, has got what? Kinetic energy E, and now changes to a quarter E. So changes to what? A quarter E. Now they say the speed of the object is now. So we want to find out the speed. We want to find out what? The speed. Because they're saying is now, that means they want to be final. Now we know that our kinetic energy has got a formula. So now the first one here for this object, we know that kinetic energy E is given by E. E equals to what? Now this is the E initial, ne? E equals to a half, okay? Equals to a half mv squared, a half mv squared, a half, that is mass, okay, times v initial, okay, which is just that's v initial squared, ne? V initial squared. Now they're saying that after this time, then now the energy changes to a quarter E. Now this is the E we are talking about. This is the E we are talking about. So now changing to a quarter E, it means it's divided by 4. So they are saying that now our new, okay, or our speed after the change is gonna be what? So to do this, let us take arbitrary values. Ne? We can choose our mass to be the constant. Maybe we can use our mass to be 2. Okay, and then we can choose our velocity to be any number which is not 1 or 0. For example, we can take it to be 4, so that we can get our initial kinetic energy as a half, okay, times what? Half times the mass which we have set is 2, half times 2, and then times v squared times what? V squared times v squared. Okay, now our v here we're saying let it be what? Let it be 4. Let it be 4 here. Let our v initial be 4, ne? Okay, so if this is 4, what energy do I get here? Okay, now as you can see that a half times 2, it gives me just 1. Then that 1 times 4 squared gives me what? 16. So here it means my initial EK is what? Is 16. It is 16 here. 16 joules. Okay. Now they're saying that what if now this energy changes to a quarter E. Now it means that when it changes to a quarter E, my speed is no longer the 4, but speed must change to something else. Let me find out. Okay, so now the E final is going to be a quarter of E, but what is our E? What is our E? It's E final here. Now our E is 16, right? So it's gonna be a quarter times the 16. What do we get? A quarter times 16, it gives us what? We are going to get 4, ne? We get what? We get 4, that is for joules here. Now the question is requiring us to find the new speed. Okay, so now we know that likewise, because we have the new energy now, which is 4, we can get our speed. Don't forget that the mass is not changing, it's going to be still 2. So I'm going to use a half, that is in the formula, times still the mass, which is 2, because that our initial mass is what? Is 2. Then times the v squared, which v I'm now looking for, that is v final, ne? Times v final what? V final squared. Okay, so now if we simplify this one here, I see that this 2 is going to cancel with this 2 here. Then I'm left with 4 equals to vf squared. So to find my v final, I'm going to find what? The square root next. So it means that my v final is going to be the square root of what? Of this 4. And you know what square root of 4? The square root of 4 is what? It is 2. It is 2. Now if I compare this v final with my v initial, which was 4, I can see that this 2 is a half of the 4. 2 is what? A half of the 4. So it means that my v final is going to be a half of the v. A half of what? A half of the v, because my v initial was what? Was the 4, and now my v final is what? Is 2. So 2 is a half of what? Of the v initial, that was 4. So my answer becomes a half v. That's my correct option. Okay, let us move forward. Let us proceed. Now next question says that the frequency of a wave is defined as what? Now frequency of the wave is defined as the number of complete waves per second passing a fixed point. So let me say it again. Frequency of the wave is defined as the number of complete wavelength passing a point or a fixed point in 1 second. So the answer here is what? The answer is C. So the answer is C here. The number of complete waves per second. Now in this paper 1.3 is the same as 1.4, so it is still the same answer here. I don't have to waste your time. The same answer here. Then 1.4, what does it say? Now 1.4 says that when two wave crests overlap, the increase in amplitude is due to what? Now the two crests look like this one here. When they overlap, like this crest here overlaps with this other one here. Okay, this one here. What do we get? Now from the principle of superposition, we see that the amplitude for this first pulse or this first wave and this one here, when we add them, they give us the resultant pulse amplitude. So now because what we have constructed has got a bigger amplitude than any of these two initially which we had, it means it's gonna be constructive interference. Let me repeat. I'm saying if I add this amplitude, maybe 2 plus 1, okay, maybe 2 plus 1 here. These are crests, 2 plus 1 here. Now my resultant is gonna be what? It's gonna be 3. So because the 3 is bigger than 2 and 1, it means that what I have constructed is bigger. So it's called constructive interference. So our answer is what? Our answer is D. Hope we are together, guys. Let us push on. 1.5 says that The reaction between hydrogen chloride and sodium hydroxide is an example of which reaction? So now hydrogen chloride here, it is an acid. It is what? It is an acid, HCl. What about sodium hydroxide? Sodium hydroxide is a base. So the reaction between an acid and a base is called acid-base reaction. So it means my answer is going to be what? It's going to be B. Okay, it's going to be what? B. Let us proceed. 1.6. Consider the diagram of two pulses shown below. That is motion. This one for this pulse. Let me take this pulse A. Now this pulse A is going to the right. What about pulse B? Pulse B, this one here, is going to the left. As you can see, it's going to the left. So if the two pulses meet at point X, the type of interference and the resultant amplitude of the disturbance will be. Now that's what they want us to find here, that when the two pulses meet at point X, this point here, you see this pulse A is moving to the right. What about pulse B? Moving to the left. So they both meet at point X. So according to the principle of superposition, the amplitude here and this one here, they're gonna be added together to give us the resultant amplitude. So let us find it out here. So this is 30. Now the one which is upwards, we usually take it to be positive. So if I say positive 30 and then plus, now the one which is downwards is always taken to be negative. So plus negative what? Plus negative 20. Negative 20. So which answer do I get? Talk to me, guys. So if I say positive 30 plus negative 20, I get what? I get positive 10. Get positive 10. Now this positive 10, as you can see, it is lower than the 30, also lower than the 20. So it means that this is called destructive interference. So these two pulses are going to interfere destructively. In other words, the amplitudes before are being destroyed to give us something smaller. Okay. Maybe somebody can say, what if these amplitudes were equal in magnitude? Now, if this one here was, let me say 20, and here another 20. So positive 20 plus negative 20 gives us what? 0. So it means that our amplitude will just be 0, and then the resultant pulse will just be like just a line which is horizontal. Okay. So let us check the answer out now. Let's check the answer out here. Now the answer here is going to be what? The answer actually, as we have seen, is going to be A, because we saw that it's going to be destructive. What about amplitude? It's going to be 10. So the answer is A, because it's already destructive, as in the amplitude has decreased. Decreased from what? From the 30 and the 20 to 10. That's what's called destructive interference. Let us proceed, guys. Question 1.7 says that an object is released from top of a frictionless inclined plane AB, as shown below. They say, which one of the following statements regarding the total mechanical energy of the object is correct? So we want total mechanical energy. Now before we get that, let us underline something here. They're saying that object is released, okay, meaning V initial is 0, okay, and then they're saying top of a frictionless inclined plane AB. Okay, that means along here, that is from A to B, it means there is no friction. No friction. And we know that in physics, if there is no friction forces here, then the system is isolated. And when the system is isolated, then there comes the principle of mechanical energy, which means that the total mechanical energy at point A will be the same as the total mechanical energy at point B. So in other words, the potential energy at this point A, that is potential energy at point A, plus the kinetic energy at point A will be the same as the potential energy at point B plus the kinetic energy at point B. So in other words, the total mechanical energy is conserved. That means E mechanical at point A is the same as E mechanical at point B. So what do you think is our answer now? Talk to me, somebody. Let's check it out. So our answer is going to be what? It is going to be C. As you can see that C says the EP meaning potential energy, plus EK, both of them at A, would be equal to the EP plus EK at point B. I hope we are together. Now this one here, it shows the principle of conservation of what? Of mechanical energy, as long as the system is isolated. Let us proceed, guys. Let us proceed to see what's next. Okay. Next page. Let's say which one of the following statement is incorrect about the properties of the physical change. So they're saying incorrect. Don't forget your English. When we say incorrect, we mean it's not correct, ne? All together. So about what? About the physical change. So let's check out. Now, when a physical change occurs, the compounds may rearrange themselves, but the bonds in between the atoms will not break. That is correct, right? That's what? That's correct. That's correct. And then physical change in matter is reversible. That's also correct. And then energy is absorbed when matter changes from a solid to a liquid. That's also very correct. And then molecules are not conserved during a physical change. That is incorrect, because we know that in a physical change, the molecules are conserved during a physical change. For example, if you have your water and put it in a cup and then put it in a freezer, it's going to convert from liquid water to ice or to solid. That's now a phase change, which is a physical change. However, if you take out that ice now from the freezer and put it back in the cup and let it cool down, you're going to surely get the same amount, the same volume. In other words, the same molecules of the water which you had before. So it means the molecules were conserved in the physical change, which was the phase change in that case. Okay. So the answer here is what? The answer is D. The answer is what? Is D. Okay. Let us proceed. Here they say that 2 molecules of hydrogen gas at STP occupy a volume of. Now, if we talk about STP, now STP stands for standard temperature and pressure, and it's about gases. Now, at the standard temperature and pressure, 1 mole of a gas, which you can say 1 molecule, has a volume of 22.4 decimeters cubed. Has what? Has a volume of 22.4 decimeters cubed. That is 1 mole or 1 molecule of the what? Of the gas at STP. Now the question says, what about the 2? What about the 2 molecules? Now because they are 2, we are going to multiply now 2 multiplied by what? By 22.4, which gives us what? Which gives us the 44.8 liters, because 2 times 2, that is 4, then 2 times 4 is 8, and the liters are the same as decimeters cubed. So it means our answer is what? The answer is B here, because only 1 molecule, or you can say 1 mole of the gas, occupies what? 22.4 liters. However, if they are 2, they're going to occupy twice that volume, which is going to be now 44.8 liters. Let us proceed. Let us proceed. Now they say here that consider the unbalanced chemical equation below. That is P4 solid plus H2 gas to give us pH3 gas. Which one of these sets of coefficients will balance the chemical equation? So what do we do now? Let us just balance it. Let us check out the answer. Now because I've got this 4 here, I have no choice but to put a 4 here, right? Put what? Put a 4 here. The moment I put a 4 here, this 4 applies to the phosphorus as well as hydrogen. So what is 4 times 3? It is 12. So it means I've got 12 hydrogen this side. Okay. But check this other side, I only have 2 here. How do I make the 2 to become 12? By multiplying by 6. Okay. So now this one I didn't multiply anything, it's just 1. So what are my coefficients? Going to be 1 here for the phosphorus. Okay. Then it's going to be 6 for the hydrogen, and then 4 for the product, which makes my answer to be 1, 6, 4. So the answer is what? The answer is B. I hope we are together, guys. If we are not, please pause the video and play it again. Yeah, next question says here that a 2 kilogram ball rolls from rest from point A on a frictionless track ABCD as shown below. The horizontal section BC of the track is 5 centimeters above the ground. The ball reaches point D, which is 30 centimeters above the ground at a speed of 1.71 meters per second. So the first question says what? Okay. Let's check it out again. They're saying that a 2 kilogram ball rolls from rest. Underline the word rest. Rolls from rest. Underline the word rest. And then the mass is 2 kg. Okay. And then from a point A on a frictionless track. So underline the word frictionless. Frictionless track ABCD as shown below. The horizontal section BC of the track is 5 centimeters above the ground. That's the height. Our height of BC is 5 centimeters above the ground. They said that the ball reaches point D 30 centimeters above the ground. So point D is what? Is 30 centimeters above the ground. So what about its speed at that point D? Speed of what? Speed of 1.71 meters per second. Now the question says something here that write down one time for the following statement: the sum of gravitational potential energy and the kinetic energy. The sum of gravitational potential energy and what? Kinetic energy. So what's the answer there? Now this one here, surely we call it mechanical energy. Guys, whenever you get the sum of gravitational potential energy and the kinetic energy, you get what? You get mechanical energy. You get what? Mechanical energy. You get mechanical energy. So our EMEC, all mechanical energy, is the answer here. That's the sum of gravitational potential energy and the kinetic energy. Let's proceed now. They say calculate the mechanical energy of the ball at point D. Okay, at point D. So this is our point D here. We need the mechanical energy at point D. Now we have seen that mechanical energy is the sum of the what? Of the potential and the kinetic energy. So at point D here, what's our E mechanical? Let's check it out. Let's check it out. Now E mechanical at point D is the same as given by what? By EP at point D plus EK at point what? At point D. So the EK is kinetic energy, right? What about the EP? It is potential energy. But how do you find EP? By using M what? By using M, that's mass, times gravity, times height at point D. What about EK? By having a half multiplied by the mass, then times speed squared. Okay, now if we substitute this on here, we're going to say what's our mass? It is 2 kilograms, as you can see, it's highlighted there. That's going to be 2 multiplied by what? By 9,8. By 9,8. Okay. And then multiplied by what? Multiplied by the height. What's the height for this point A? I mean point B, point D. Height is 30 centimeters, ne? But we must use standard units, ne? So centimeters must be converted to meters, ne? So divide by what? Divide by 100. Okay. And when we're done with that, we also get our EK. It's gonna be now plus what? Plus. Now how do you find EK? It's gonna be given by a half times mass times b squared, ne? That means a half times what? Times 2. That was my what? Mass for the ball. That is 2. Multiplied by what? By 1,71 squared. 1,71 squared. I think I need some space here. Okay. Yes, let me do it again properly. So I'm getting what here? I have a half times 2 times 1,71 squared times what? Times 1,71 squared, right? Okay. Let's get our calculator out to check out our answer here. Okay. So here we have our calculator. I'm gonna put brackets, ne? I'm gonna put what brackets here? Okay, so we're going to find the MGH and then the what? The kinetic energy at point D. Right. So open brackets, start with MGH, that's the mass was 2, multiplied by G, that's 9,8, then multiplied by the height, which was 30 over 100, ne? That's 0,3. When you are done, then you add what? You add the other half, mv squared, ne? That's 0,5 is a half. Again, I can put as it is. That is a half. Is it? Nope. Okay, that's a half. That's 0,5, ne? 0,5 multiplied by what? Mass, which is 2, multiplied by 1,71 squared. 1,71 squared. And close the bracket. Okay, so what's our answer here? The answer is 8,8041. So 8,8041. I hope we are together. 8,8 is our answer here. So the E mechanical at point D is what? It is 8. It is 8,8 joules. 8,8 joules. Hope we are together. 8,8 joules. Okay. Next question says what? It says that the initial height of the ball at point A. So I want the initial height of the ball at point A. Now at this point A, which you see here, guys, I can see that point A is also part of the tracker ABCD, which means that the mechanical energy at point A is the same as mechanical energy at point D. Somebody can say, why are you not talking about BC? Because I don't know BC yet, so I use what I know because they're all the same track anyway. So it means that E mechanical at point A is the same as E mechanical at point D. So I'm going to find out the E mechanical at point A, that's mechanical energy, then I'm going to equate it to E mechanical at point D. Let's find it out now. Now, how do you find E mechanical here? You're going to add what? You're going to add EP plus EK. EP plus what? EP plus EK. EP plus EK. So, how do you find EP? Talk to me. Now, EP is MGH, ne? But the mass is still 2. It's still the same ball. That's going to be 2, ne? Times 9,8. That's MGH, 9,8. Okay. What about my height? That's what I'm looking for, times height H. Okay. And then plus I have mv squared. But at point A, that's where the ball was released, ne? Meaning that its initial velocity is what? Is 0. So it's gonna be 2 then times 0 squared here, because they said it started from what? From rest, ne? Which means V initial is what? V initial is 0. So it's gonna be times 0 here, ne? But squared, ne? Okay, so now everything is gonna be equated to what? To the E mechanical at point D, because they all lie along the same track, ne? So I'm gonna use 8,8 here. Hope we are together. 8,8. 8,8. So this side, if I compute my things here, this is gonna be 2 times a half, which is 1. 1 times 0 squared gives me 0. What about 9,8 times 2? It gives me 19,6H. So I have 19,6. Then with my height H equals to what? Equals to this 8,8. So I divide 8,8 by what? By the 19,6 to get my height H. So divide both sides by what? By 19,6. By 19,6. By 19,6. Okay. Let's check with our calculator. 8,8 divided by 19,6. What do we get? What do we get? Let's check it out. 8,8 divided by what? By 19,6. Okay. Now we have 8,8 divided by 19,6. Okay, what do we get? We get 0,4489795,918. So if I take to the small place, it's gonna be what? 0,45 meters. 0,45 meters. Okay. When I go to the whiteboard, it's gonna be H. There's H here, by the way. Let's keep there's H here. It's gonna be H. H equals to 0,45 meters. 0,45 meters. 0,45 meters. Okay. Now that's our initial height of the what? Of the ball at point A. Let us proceed, guys. What next do we need now? Let's check the question. It says that the speed of the ball while it moves between points B and C. Now again, points B and C, they are along the frictionless tracker A, B, C, D. Ne? So it means that E mechanical along BC, ne? It's still what? The same as E mechanical at point A or point D. So I'm gonna use E mechanical at point BC equals to E mechanical at point what? At point D, right? Let's check it out. Let's check it out here. So I'm going to say that E mechanical along BC, and that's what? That E mechanical E mechanical along BC is the same as E mechanical along what? Along ED. I mean at point D, because the flow is what? The flow is frictionless. The surface is frictionless. Okay, so at point D. But what does E mechanical means? It means I'm going to add EP plus what? EP plus EK. EP plus EK along BC. Along BC. EP plus EK along BC. When I'm done, I'm going to equate it to what? To 8,8. That's the E mechanical at point D. It was 8,8 joules. Okay. Now everything. Don't forget this along BC. Ne? This is E mechanical along what? Along BC. Along BC. Now to get our EP, we're going to multiply again. mgh, that's mass, times gravity times height. Okay. When we are done, we are going to add a half mv squared, a half what? A half m, a half mv squared, half m v squared. Okay. Now this v is the speed along BC. Don't forget. Then equate to what? Equate to 8,8. Equal to 8,8. Okay. 8,8. Alright. Now if I check here, the mass is still 2 kilograms. That is going to be 2 multiplied by what? Multiplied by 9,8. Okay. 9,8 multiplied by the height. Now the height of BC above the ground is what? It is 5 centimeters. Ne? So divide by 100 gives you 0,05. Ne? So it's going to be 0,05. Okay. And then plus a half times the mass, which is 2. So that times 2 here. Then times v squared. Okay. Now this is the speed along BC. Ne? Times v what? V squared. Everything equals to what? Equals to 8,8. Equals to 8, what? 8,8 joules. 8,8 joules. Okay. Now if I simplify here, this 2 will cancel this 2 here. Then I have 2 times 9,8 times 0,05. What do we get here? Talk to me now. 2 times 9,8. 2 times 9,8. What do we get? 2 times 9,8 multiplied by 0,05. What do we get? 0,98. Okay, so we get 0,98. Let's go back here. So that be 0,98 this side, guys. 0,98, and then plus what? Plus v squared, ne? Because the other one cancelled with what? Cancelled with the 2. Okay, so everything equals to what? Equals to 8,8, ne? 8,8. Now if I subtract 8,8 minus 0,98, I'm gonna get v squared equals to what? V squared equals to 7, what is 8,8 minus 0,98? 8,8 minus 0,98. 7,82. 7,82. Now because you don't do math light, how do you get v from here? I'm going to square root both sides. Ne? I do what? I square root both sides. So square root both sides. If I do so, square root both sides, even here, square root both sides. What's my answer? What is my answer? Square root both sides. What's my answer? Talk to me now. Now if I do get the square root of that one there, it gives me 2,8 meters per second squared. 2,8 meters per second. Okay, so my speed v is gonna be 2,8. Yes, 2,80 meters per second. So this is my speed v of the ball along BC, which is also frictionless. Okay, hope we are still together. Let us proceed, guys. Let us proceed. Now they say here that the 2 kilogram ball is now replaced with a 4 kilogram ball. Compare the speed of the 2 kilogram ball at point D. Choose from greater than, smaller than, or equals to. Give us for your answer. Now, you know what? The speed of the ball along the track does not depend on the mass of the ball. Let me say it again. The speed of the ball along this tracker ABCD, does not depend on the mass of the ball, but instead depends on the height, initial height of the ball. So because I've not changed the height, it means the speed will be the same. So the answer is what? The answer is equals to. The answer is equals to. Why? Because the speed of the ball does not depend on the mass, but depends on the what? Depends on the what? On the initial height. Initial height of the what? Of the ball. So the answer is what here? It is equals to. The answer is equals to. The answer is equals to. Let us proceed, guys, here. Question 3. It says that the diagram below represents a transverse wave produced by source A. Okay, as you can see, this is our amplitude in centimeters. This is the time in seconds. Okay, define the term amplitude of the wave. Now, amplitude is the maximum displacement of the wave from the resting position. Okay, it is what? It is the maximum displacement of the wave from the resting position. And like if you can see from here up to here, that's our amplitude. Okay, let us proceed. They say write down the amplitude in meters of this wave. So now here we have 50 centimeters here, and because these are centimeters, must convert it to meters. So what's going to be? It's going to be what? It's going to be our amplitude A equals to 50 centimeters, the same as what? 0, the same as 0,5 centimeters. 0,5 centimeters. Rather meters, ne? 0,5 meters. 0,5 meters. Okay, so next question says what? It says that determine the period of this wave. Determine what? Period of this wave. So what do we do here? To get our period. Talk to me now. Talk to me now. How to find the period of this wave? Now, period is the time taken for one complete wavelength to pass a fixed point. So, all you can say, the time taken for 2 points in the phase to pass a fixed point. So now this point here and this point here, they are in phase. So it means this time taken, which is 8 seconds, is our period. So our period is what? Is 8 seconds, guys. It is 8 what? 8 seconds. It is 8 seconds. 8 seconds. Okay. Now here they said that calculate the speed of the wave if the wavelength is 0.8 meters. Now they gave us wavelength here. What does the formula say? What does the formula say? What does the formula say? Now if you have the wavelength and then the frequency, you can find your speed. Okay, so the speed V equals to wavelength plus the frequency times what? Times lambda. Lambda is the wavelength. Lambda is what? Lambda is the wavelength here. So now this F frequency is the reciprocal of the period. So it's same as saying 1 over what? 1 over t. 1 over t here to give us our frequency, then times what? Times wavelength here, which is lambda. Okay. So if I substitute, I'm gonna get what? I'm gonna get here 1 over 8. Okay. Multiplied by what? Multiplied by 0.8, because they say that is the wavelength there. 0.8 meters. So what's my answer then? So my answer is going to be what? It's going to be 0.1 meters per second. That's my speed for this wave, 0.1 meters per second. Okay. And then they said distance d on the diagram. So distance d is how many wavelengths? Let's find out. I want distance d on the diagram. Let me check it out again. Now this distance d on my diagram here, as you can see that from this point here to this point here is one wavelength. Also from here to here is another wavelength. Those are 2. Then from here to here is half. It's half of the wavelength. So it means that point D is how long? It is 2,5 wavelength. This point D is 2,5 wavelength. So to get my point D, I multiply 2,5 times the given wavelength. They gave me what? They gave me 0.8. So it means that my point D is given by what? By D equals to 0.8 multiplied by what? By 2,5. Okay. So times 2,5 times 2,5. So which answer do we get here? Here 0.8 times 2,5, I get what? I get 2. So it is 2 meters. So my distance D is what? Is 2 meters. 2 meters. Okay. Thank you so much for watching. We continue from there. Thank you. Indeed, my name again is Patrick Kamala. I'm a tutor.